Hello, this video is for Lesson 3 of Chapter 3, so it's Lesson 3.3. It is titled Solving Equations with Variables on Both Sides. Our objective is to solve equations with variables on both sides. The review vocabulary for this lesson is equation, solution of an equation, and inverse operations. So, Spanish Club. The Spanish Club is arranging a trip to a Mexican restaurant in a nearby city. Those who go must share the $60 cost of using a school bus for the trip. The restaurant buffet costs $5 per person. How many students must sign up for this trip in order to limit the cost to $10 per student? In example 2, you will see how to use an equation to answer this question. Every equation in this lesson has variables on both sides of the equation. You can solve such an equation by getting the variable terms on one side of the equation and the constant terms on the other side. So we're going to be talking about, we are going to have equations in which we're going to have a variable show up on both sides of the equation. And we're going to have to get the variables to one side and all the constants, that is all the other numbers that do not have variables, values that do not have variables, over on the other side so that we can then isolate the x, and we all know about, or isolate the variable. It doesn't necessarily have to be an x, but whenever it comes down to what does it mean to solve an equation, it means that we're going to isolate the variable. So looking at the next slide here, we see example 1. We note that we indeed do have variables on both sides of the equation. So example 1 says solving an equation with variables on both sides, and as I said, you can see that we have that situation here. We also have constants like -5 and +13 on both sides of the equation as well. So we want to get it down to where we see this line right here, down here where it says to simplify, to where we get equations on just one side. As a matter of fact, at this point right here on this line, we have equations just on the right as opposed to on the right and left. So let's see how that's done. So we're going to write the original equation. So we copy the original equation here. Now we're going to subtract 7n, and in the past we've been subtracting just constants from each side, but you can subtract a value or add a value, either one, on to either side where you have variables. So here we subtracted 7n from each side, and let's see what happens there. So the positive 7n is going to be canceled out by the negative 7n, so we just lose the 7n's on the left, and we end up with just -5. Over here on the right, we've added a -7n, and whenever we combine like terms, this 10n and the -7n, well, 10 minus 7 is 3, so we get 3n. And of course, we can see that this 13 has been carried down for each step. Now that we're at this part, now this looks a lot like a two-step equation that we've seen before, right? Well, we know how to handle that. The 13's tied to the 3n by addition, so we're going to use subtraction, the inverse operation, or like I like to say, the opposite operation. And we're going to subtract the very number we wish to get rid of, which is 13. Now the positive 13 and the negative 13 is going to have a net value of 0, leaving us with just 3n. But if we're going to add -13 over here, we also have to add -13 over here. So we have -5 minus 13, which is the same as -5 plus a -13. So it's going to get even more negative, become -18, bringing down our 3n. Now the 3 is tied to the n through multiplication. The opposite operation is division. We're dividing by the very number we wish to get rid of. And what we do to one side, we do to the other. The 3's cancel each other, leaving us with just n. And negative divided by positive equals a negative, and 18 divided by 3 is indeed 6. So the solution is -6. Now, looking over here at the study strategy, there is another way to do this. To solve the equation example 1, you might choose to first subtract 10n. So what if we took away 10n from each side? You would obtain the equation -3n minus 5 equals 13. When you solve this equation for n, you get the same solution as in the example. Now, the thing about it is that I've always encouraged my students to try to end up with a positive coefficient for your variable whenever you do this, because what happens is, let's go ahead and work that out like they'd said. Let's do 7n minus 5 equals 10n plus 13. So if I go ahead and I subtract 10n from each side, so minus 10n, and subtracting 10n from each side, what happens is we end up with, well, these cancel each other out. We get 13, right? And 7 minus 10 is negative 3n minus 5. Well, then we're going to add 5, right, and to each side. So if we add 5 to each side, then we end up with these canceling. We get negative 3n equals 18. And then you have to divide by negative 3. And I guess either way that you would like to do it, it's going to work out all right, because it's 18. Positive divided by negative is negative, and 18 divided by 3 is 6. So you see, you still end up with the same n equals negative 6. However, as you move along through the process, you're going to find that it's a little bit more, I don't know if tolerating or pleasurable or whatever the word might be, preferable. There you go. It's preferable that we have our n, our constant, that we have our coefficient that is tied to the variable as a positive, as opposed to here where we have it as a negative. So your choice, either way you want to go with it. I have a tendency to always subtract the one with the lesser value, lesser absolute value, in order so that I can end up with a positive n. I don't know if that makes sense. You'll see as you work through it, you'll start realizing, oh, if I subtract this variable on this side, or if I subtract this value on this side, then I'll end up with a positive coefficient instead of a negative one. So it's all a matter of preference, so choose how you like. All right, so here's a couple examples here. Let's do 1 and 3, I suppose. Number 1, we have 5n, and minus 2 equals 3n plus 6. So here's an example about how it could be positive or negative. If I subtract 3n, then I'm going to have 2n over here, right? But if I subtract 5n, then I'm going to have negative 2n over here. So the fact that I want a positive 2n, I think I'll go ahead and subtract 3n from each side. So minus 3n, minus 3n, and then these will cancel each other out. 5 minus 3 is 2, so I'm going to have 2n minus 2 equals, and I still have the 6. Now let's go ahead and add 2 to each side, and those will cancel, leaving us with 2n, and 6 plus 2 is 8, and then divide both sides by 2, and we get n equals 8. All right. On number 3, we have m minus 1 equals 9m plus 15. And it looks like, well, let's go ahead and subtract 1m from each side. So minus m and minus m. So these will cancel each other out. Remember, this is a negative 1 right there. So negative 1 equals, and 9, and remember that's a 1 there. 9 minus 1 is 8. So we have 8m plus 15. So now let's get that 15 over on the other side. So we want all of our constants on one side, all of our variables on the other. So let's subtract 15, and we're subtracting 15 over here as well, which is the same as adding a negative, correct? So I'm going to end up with a negative 16 equals 8m. Now let's go ahead and divide both sides by 8. The 8's will cancel, leaving us with m. And negative divided by positive is negative. 16 divided by 8 is 2. So we have m equals negative 2. Here we have example 2, the restaurant story. So we are going to figure this one out. How many students must go on the Spanish club trip to the Mexican restaurant as described on page 131? That was that first slide we were looking at. in order for the cost per student to be $10. So let's see what our solution is. We're going to let S represent the number of students, and we're going to write a verbal model. Well, we know that if we have the cost per student, we want to keep to $10, right? So this is going to be our money that the students are paying. And this is the student cost over here. So we want what they're paying to be equal to what it cost. Well, what they're paying is determined by the cost per student and the number of students. How much the cost is altogether is, well, it's the cost of the buffet, which is $5. That's multiplied times the number of students. And then also you've got the $60 that the bus trip cost. So that's how this is set up. So it's $10 per student is what they want to pay. And on the right side is what it costs, $5 for each student at the buffet and $60 for the bus. So with that said, it looks like we're going to subtract 5s from each side. We've added a negative 5s here and negative 5s here. So 10 minus 5 is 5. 5 minus 5 is 0, so we're just left with the 60. Now we divide both sides by 5, and we end up with just s on the left. 60 divided by 5 is 12. So in this case, the club needs 12 students to go on the trip. And I remember looking back, how many students do we have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 of them. Looks like they need one more. Or maybe they could get the bus driver to throw in $10. Or what about the teacher? They need a chaperone. So maybe the teacher could pay the other one there, and then they would have enough to cover the cost, right? And those do look a bit tasty. I believe that's pronounced flautas, but they're fried tacos. They're a Mexican specialty. Used to get those in Kansas City at a little restaurant we used to call Hole in the Wall. So at any rate, let's go on. Number of solutions. So we're going to talk about the number of solutions that there are to an equation. So far, everything we've been doing is there's just one solution. We solve it, and there's just one number, x equals 5, m equals negative 12, whatever, right? So now we're going to investigate that there could be maybe possibly an infinite number of solutions, or maybe there's no solution at all. Let's see what that's all about. So number of solutions, when you solve an equation, you may find that it has no solution or that every number is a solution. So if every number is a solution, that means you have an infinite number of possibilities for a solution. So an equation with no solution, let's see what that looks like. So if we solve 5 times the quantity of 2x plus 1 equals 10x, we rewrite the original equation, and then we distribute the 5 into the 2x and get 10x. 5 times 1 is 5, and we end up with 10x plus 5 equals 10x. Well, notice that 10x plus 5 equals 10x is not true because the number 10x cannot be equal to 5 more than itself. So if you think about whatever x is, we have 10x on the left, 10x on the right, and in this case we end up with a situation where whatever we plug in for x, pick a number, 2. 20 plus 5 is 25. 10 plus times 2 is 20. 25 is not equal to 20. No matter what number you plug in there, you can plug in a 5. 5 times 10 is 50, plus 5 is 55. So you'd have 55 on the left. 10 times 5 is 50. You'd have 50 on the right. 55 is not equal to 50. So the equation has no solution. As a check, you can continue solving the equation. So let's go ahead and do that. And this is usually what I encourage my students to do. This may not be so obvious right here, but whenever we get down here, we can tell that it's absolutely obvious that there is no solution. So if we subtract 10x from each side, we end up with just 5 on the left. These two 10x's cancel each other out, so you have a 0, and you end up with 5 equals 0. Is this true? Indeed, it's not true, so the equation has no solution. So if you go through the steps and you solve an equation and you work it out and you end up with something like this, where you have an untrue statement, right, then that means that the equation has no solution. So let's look at solving an equation where all numbers are a solution. So we have 6x plus 2 equals 2 times the quantity of 3x plus 1. Well, let's rewrite the original equation. Now let's distribute this 2 into the quantity of 3x plus 1. 2 times 3 is 6. The x goes along for the ride. And 2 times 1 is 2. And so we end up with 6x plus 2 equals 6x plus 2. We have something equals something. And often I'll encourage my students to go ahead and continue on. If that's not obvious, then if we keep going and we say, okay, let's subtract 6x's from each side. So we subtract 6x from each side. Those cancel, we get 2, and those cancel, and we get 2. Oh, look at that. We got 2 equals 2. We can't solve it any further. We just have something equals something. And so this is a true statement. You can't work it out any further. And it turns out to be that no matter what number that you plug in for the value of x for that variable, it is going to produce something like this. You're going to get down to where something equals itself. Whenever that happens, it is said that, well, it's said because it's true, that no matter what value you plug in for x, it's always going to be a true statement, regardless. So, example 5, solving an equation to find a perimeter. And this is a geometry, right? So we're finding the perimeter of a square. And what's interesting to note, and is quite often the case in assignments where students will get an answer wrong because they're not paying close attention to what the question is asking. So study strategy, make sure you understand what you're being asked to find in a problem. In example 5, you first solve for x, but the problem asks you to find the perimeter of the square. So remember, perimeter is the distance around the outside, so we go around the outside here, right? But first, in order to do this, we have to know what the length of each of these sides are in order to know what the perimeter is. So a square has 4 sides of equal length, so write an equation, solve for x. Well, if a square has equal length on its sides, then that means that 2x has the same value as x plus 4. So we could just set that up in an equation. 2x equals x plus 4. This is, at first this might look difficult to figure out, well, how am I supposed to know what x is? Well, we take something that we do know. The sides of a square are congruent. Congruent means same size, same length, same shape, etc. So these two sides are congruent, or that is to say they are equal to one another, so we just set them equal to one another. Solve for x and we get x equals 4. Now that we know that the side length is 4, if the question were what's the perimeter for the square, and you just entered the answer 4, or you wrote down the answer 4 and submitted the answer 4, then it would be incorrect because the question is asking you to find the perimeter of the square, not the side length. So now that you know what the perimeter of the square is, now you can find one of the side lengths. So to find the side length of one side by substituting 4 for x in either expression. So we could go x times 4 right here, or 2x. So we have 2x, substitute the 4, 2 times 4 is 8. We know this side length is 8. We could also check it over here, right? If x is 4, x plus 4 equal 8. Indeed it does. So we know that both sides here have a value of 8. Now all we have to do is multiply 8 times 4 right here to get the perimeter, and we know that the perimeter is 32 units in length. So that brings us to our guided practice here at the end. Describe what steps you would take to solve 8x plus 5 equals 2x minus 7. Well, we have to get all of our variables on one side and all of our constants on the other. So we would most likely want to subtract 2x's from each side. And if we do something, let's look at this. Once you really get good at this, you'll be able to move your variables to one side and your constants to the other in the same step. And an example of that is, I'll rewrite the problem. 8x plus 5 equals 2x plus or minus 7. And now I'm going to subtract 2 x's from each side, right? But at the same time, I know I want to get rid of this negative 5, so I'm going to subtract 5 from each side as well and do this all in one step. Then 8x's minus 2x is going to give me 6x, and these 2x's will cancel each other out. But these two 5's will cancel each other, and I end up with negative 7 minus 5, which is going to be negative 12. And then I'm all the way down to where I have all my variables on one side, all my constants on the other, and at that point, I just need to divide by 6, right? And that's going to leave me with x on the left, because the 6's will cancel. Negative divided by positive is negative. 12 divided by 6 is 2, so the solution would be x equals 2. If I look at some of the other ones here in the skill check, oh, we skipped number 2, didn't we? Explain why the equation 5z plus 2 equals 5z has no solution. Well, that's because if I've already got 5z on each side. So whatever I plug in for z, this and this are going to have the same value. But on the left side of the equation, I'm trying to add 2 after I plug in that value. So we're never going to be able to find anything that satisfies this solution because we have 5z on both sides, but we have an additional 2 on the left. So you're never going to be able to find a solution for that. Well, because if we go ahead, let's look at that. 5z plus 2 equals 5z. So you might say, what could we do? I don't know. Subtract 5z from each side. Let's try that. Minus 5z. And those cancel. Those will cancel. And I end up with 2 on the left. And what's on the right? Well, 0. Is 2 equal to 0? No, it's not. This doesn't work. So since we end up with a false statement at the end, after working it all the way down, we find that there is no solution. Let's look at a couple of them here in the skill check area. Let's pick, I don't know, let's pick 5 and 6. Let's go ahead and work out 5. We have 15 minus 4x equals 42 minus 7x. So it looks like I have a choice of either adding 4x to each side or adding 7x to each side. Well, if I add 7x to each side, actually, let me add 4. If I add 4x's to each side, plus 4 plus 4x, these are going to cancel each other, and I'm going to end up with just 15, 42, and then negative 7x plus 4 is going to be negative 3x. And you could work it from there, but notice that your coefficient with the variable x is actually a negative coefficient. Let me hit the back arrow here, go all the way back, almost there. Now, and it's because these coefficients are negative in the first place that this seems a little backwards from our thinking. But instead, what if I add 7x's? Well, if I add 7x's, that's going to take this negative 4 from a negative 4x up to a positive, right, by adding 7. So let's go ahead and try add 7x. Because remember, I kind of like to target my coefficients to be positive. So the 7x's will cross each other out. And then I get negative 4 plus 7 is positive 3x. And I still have 15 plus, and I have the 42, right? Now I could go ahead and subtract 15 from each side. Minus 15. 15's will cancel. End up with 3x equals. And then 42 minus 15. Well, I'll do that over here on the side. 42 minus 15 is the same as 42 plus negative 15, right? So let's turn it over to a sum instead of a difference. Now I'm adding a positive and a negative number, which means I actually have to subtract. So I'm going to do 42 minus 15. Looks like I need to borrow 1, and this becomes 12. 12 minus 5 is 7. 3 minus 1 is 2. So I end up with 27, but the question is, should it be positive or negative? Well, the 42 has a greater absolute value than the negative 15. So the 42 is positive, so our answer is going to be positive. So we end up with 27. Now divide both sides by 3. What we do to one side, we do to the other. Cancel the 3. We end up with x equals positive divided by positive is positive. So we know the answer is going to be positive. And 27 divided by 3 is 9. So x equals 9. Next, we'll look at number 6. And number 6 is 14 plus 5y equals 50 minus 4y. So I'm thinking, well, let's take away, or let's add 4y, because if I add 4y, then that's going to keep this 5y over here positive, and it's going to make it 9y, correct? So those 4y's are canceled. I still have a 14 over here, and I have 50 here. So the next step is subtract 14 from each side. So we have the 9y by itself on the left, and 50 minus 14. Well, if you think about it, 50 minus 10 is going to bring us down to 40, and then minus another 4 is going to give us 36. Now let's divide by 9. 9's a cancel. We're left with y equals, and 36 divided by 9 is 4, so y would equal 4. And then finally, let's look at the error analysis here. Describe and correct the error in solving the equation 4x plus 7 equals x minus 2. So we start off with rewriting the equation first. 4x plus 7 equals x minus 2. All right, it looks like they chose to go ahead and add a negative 4x to each side. Good, that's good so far. All right, the 4x's would the 4x and the negative 4x would cancel each other, leaving us with just 7. That looks all right. And then we have x. Remember, this is 1x right here. So 1x minus 4x's, well, 1 minus 4 is negative 3, but they put a positive 3. So this should be a negative 3 instead of a positive 3. So right here at this line is where the error was made, which ended up resulting in an incorrect answer. And if the student who did this work wanted to make sure that they had a correct answer, they could always plug that back in to the equation here, and they'd find that it would not work out. All right, so that is all of my examples and instruction for lesson 3.3, solving equations with variables on both sides. Thank you.